third and last type of radiation then we have to look at is gamma. Okay, so we said when a nucleus is unstable, it will decay and it will emit some type of radiation. So once again, gamma comes from the nucleus, but unlike alpha and beta, it's not an actual particle as such. It's an electromagnetic wave. Now you will do about electromagnetic waves in year 12, but just to recap, we have something called visible light, and visible light is an electromagnetic wave. However, if we keep increasing the frequency of light, it goes through all the colors of the rainbow, so red, orange, yellow, green, blue, indigo, violet. If we increase the frequency beyond violet, we get to ultraviolet. Okay, we can't see it. It's still light, essentially. It's just not visible to humans. Some birds and some bees can actually see in ultraviolet. If we go lower frequency than visible light, we get to infrared. Okay, all hot objects emit infrared. It's exactly like light. Our eyes just aren't sensitive to it. Some snakes can kind of detect infrared. So if you were in a completely pitch black room with a snake in it, it could essentially see you because of the infrared light that you emit. We've talked about that before because that's kind of our heat radiation. Go lower than infrared and you get the microwaves. Go lower than that and you get to radio or TV waves. So we're increasing the frequency here. If we go higher frequency than ultraviolet, we then get a type of light really that isn't visible, but it's called X-rays. And it's those that are used to take medical X-rays. However, if we go higher frequency than that, that's when we get to gamma rays. Okay, so our gamma radiation here is really the highest frequency electromagnetic radiation there is. So it's got a huge amount of energy because of that then. But its other properties are like that of light. So the relative atomic mass of it, well, it's light. In fact, it's as light as you can get. It's zero. It doesn't contain any particles. The charge is a wave. Doesn't have any charge. Therefore, its ability to ionize is low. By that we mean it's not very good at removing electrons from atoms because it can't affect them by repelling or attracting them because it doesn't have a charge. What it can do is give them enough energy that they move fast enough that they escape. So it still can cause ionization, just not as much as alpha and beta would. However, it can pass through objects in the same way that visible light can pass through glass and air and water. Gamma rays can pass through concrete. So in fact, to stop gamma, we need really, really thick concrete, or we need really, really thick, heavy, dense metals such as lead. So it has the best or highest ability to penetrate through materials. Okay, what I want you to do next is below this, I'll draw a little arrow. I want you to draw out a little summary chart and fill it in your notes, please.